Okay. Hello and welcome everyone. So this is the re-recording of the Ethereum Engineering Group meetup that we did yesterday here in Brisbane, Australia, which unfortunately the live stream stopped halfway through. So let's share my slides. Okay. So before I start and getting too far, I should say that this is my perspective, and yep, please write comments into the chat for the YouTube video when it goes up. And if you've got different perspectives, I'm sure we're all very interested to hear them. So also some of these slides were created by John and David, John Wolpert and David Highland Wood. So thank you for their slides and their inspiration. So if you look at the web, in the early days, you know, you've got all sorts of different companies that were big, like AOL, Netscape, Lycos is one that's not even there. You know, and they were big and they existed for maybe 5 years, and then you know, they lost their preeminence, and then you've had, say, Microsoft came up, and then, you know, now we've got Google, and now we've got these two companies that have just gone over $1 trillion, being Amazon and Apple. You know, and will they just be 5-year wonders, or will they be a long-term player? You know, Apple has, you know, has been around for a very long time now, since the very early 80s, or maybe late 70s, and it's come to preeminence and then gone off, and now it's come back. So will some of these others come back? It's an interesting thing to think through. And so with blockchain platforms, we've got Bitcoin, which has been, you know, was obviously the founder of it all, the starter of it all, and very big. But then we've also got Ethereum and Corda and Hyperledger Fabric are big now. And then, you know, maybe we've got these others that will be rising. And so, you know, even say Amazon as far as a cloud service provider. And so where will we be in 5 years? Will some of these be long-term players, or will they, just after about 5 years, will they fade? It's something to try and think through. And so if we look at the blockchain platforms that are out there, there are actually should be about 1,000 icons here for 1,000 different blockchains. And not all blockchains are as important as others, I'd say. And so Bitcoin and Ethereum's icons are actually bigger than the other ones. And I think that's because there's a lot more money involved and a lot more things happening there. And Bitcoin, though it is still important, it doesn't allow you to do, say, smart contracts. It doesn't allow you to do programmable logic on the blockchain, whereas Ethereum does. And so, you know, really, I think it's losing its importance, and as well, the Bitcoin people have had real problems with upgrade. So real problems with essentially being able to do hard forks and say change the actual Bitcoin protocol. That's something that's been quite hard for them. Whereas I think Ethereum has over time evolved. So with Ethereum, it's got Ethereum Mainnet in particular, you've got strong authenticity and strong non-repudiation. So what I mean by that is that you can't revert history. It doesn't matter about how much compute power you've got. You cannot revert it because the amount of compute power is just, you know, beyond what people have, even state-based actors. And so it means that, you know, when something's in Ethereum Mainnet, it's locked in for good. There's no changing it. And so you should be thinking perhaps that all of these other blockchains should consider leverabilities. And so if you're a smaller public chain, then, you know, your state could possibly be reverted, and you could have, say, attacks that, you know, could change things. Or if you're a consortium-based network, you could imagine that the players in the consortium network could collude to revert state because, you know, maybe the state has ended up somewhere that they don't want it to be and that they prefer to revert and then move forward again. But if you're a regulator, you might not want that history rewrite. So there are real advantages in forcing the state of a ledger to be pinned, say, to mainnet, or in some other way you could have these smaller chains leveraging Ethereum mainnet. And as well, Ethereum mainnet, though it's, you know, great with these non-repudiation properties and authenticity, it's not, you know, the best chain for all jobs. And so invariably you've got security and you've got performance, you know, and it's a bit of a trade-off. And so different chains offer different features. And so you might choose to use a different chain, and maybe that chain is specifically designed for your use case. So that might be more applicable to your use case than, say, Ethereum or Ethereum mainnet. Or you might use Ethereum as a consortium network, which you can do. You can use it as a separate network unto itself. And so if you were to leverage the non-repudiation qualities of mainnet, then you could have the other chains used for what they do best, but then use it for what it's really good at. And so when I've been thinking through, well, what could you possibly do on mainnet that would be useful, you know, from these other blockchain perspectives, I've thought of address book, pinning of state, and coordination contracts, and to try and expand on those first two. So for an address book, what we're talking about is you need to allow entities which haven't previously interacted to be able to securely establish communications and securely establish a blockchain and be able to do things. And so if you think of, you know, when you go onto the internet and you go https example.com, you don't know where example.com's servers are. Even if you did, how do you prove that the connection you've got is with them? And so you use DNS, domain name service, and the certificate authority system to prove that you really are, locate the server and then prove that you really are interacting with that server. So for the blockchain era, we need a similar sort of thing, and probably we need something that's more, that has slightly different properties and is more secure. So, you know, we're trying to locate information like an IP address or security keys. We want it to be decentralized. So we've gone to all this effort to have these decentralized blockchain platforms, but then if our address book is centralized, then sort of the whole thing's blown. So it's got to be decentralized, and we want it to be censorship resistant. So the current domain name service in system, for instance, you have these delegate domains, and so if you've got one of those delegate domains or subdomains, then the actual owner of the parent domain could just delist you, and then you're gone. You're off the air. So we don't want that censorship resistance in any address book system. And the second last bullet point there about assembling into multiple trust groupings. So what that's all about is that you could imagine, you know, like you might have one trust grouping might be, I don't know, certain, you might have an authority which says, all right, all of the people that I've got in my list, they're ones that I've done really good due diligence on. Whereas then maybe you've got another group and their list contains organisations that maybe they self-sign, or maybe there's some social sort of authentication, but maybe it's not quite the same level of due diligence. So you might want to do different trust levels, but then as well, you might want to list with multiple providers of trust, and so not be tied to the one single provider. But also you might want to have, say, be listed with a set of providers, but then maybe, say, a government authority, for instance, could say, all right, I'm going to list all of the banks in Australia. And so you're only, and they say they're a bank, you're only allowed to deal with banks or organisations that are in my list. And so for regulatory purposes, for instance, you could have a trust grouping. So And so I think that's the overall usage that you'd be trying to do for a really good address book. And so if you store it on Ethereum mainnet, I think then you're in a good situation. And we came up with, within Pegasus Protocol Engineering Group in Consensus, something called Ethereum Registration Authority. And so this is a distributed DNS system, and it allows you to locate information based on domain names. It's decentralized, censorship resistance. It doesn't rely on DNS, allows domains to be assembled into multiple trust groupings. We've got a research paper that's out at that link. And we've also got a GitHub repo, so you can have a look at the code there as well. So another area is state pinning. So earlier I was talking about how, you could have these public chains have their state reverted, or they could have some other attack. And you've got these consortium chains where maybe you could have collusion to revert state. And so the idea is that the pinning would allow you to not have that reversion. But certainly if you're in a consortium chain, though, you don't want to be going and revealing who the participants of the consortium chain are, because the whole reason for doing a consortium chain might be that, you want to interact privately. So you need to be able to do it anonymously. So given those thoughts, in Pegasus, we've in the midst of coming up with an anonymous pinning approach, which will be particularly good for sidechains, and allows the pinning of blockchain state without revealing the participants of the sidechain. But it still allows for pins to be disputed. And it also hides the rate of transaction. So you can imagine, say if, I don't know, say Sandra and I are doing, have a sidechain that, or a blockchain that we're interacting on. We don't want to reveal to everyone that maybe we're doing one transaction every month or 100 transactions a second, because say if we're two organizations doing something, then our competitors might be able to derive information from the rate of transactions. So you really want to hide that too. And so we've come up with a mechanism for doing that. And the research paper will be out soonish in the coming months. The GitHub repo should be open sourced in the coming weeks. So another idea, and it is sidechains on demand. And so I've gone and done a bit of a spelling error there in the title. Please excuse it. So the idea is that you want to have ephemeral sidechains. And so this is something that I think, we'll see more of in the future. And so similar to how you could do, say, https example.com, where you have you and example.com, you create a secure connection between the two of you. You transact some business, you do some communication, you update state, and then that secure connection goes away. So you could imagine you could have, you could instantiate a blockchain or a sidechain, and then, maybe there are some cross-chain transactions that occur, and maybe you even fire something up at mainnet as well. And you have these transactions, and then once they're finished, then maybe you archive that chain, and so it's not a long-term persistent chain. And so how many sidechains or, blockchains do I see there being? I think if we can get this on-demand ephemeral sidechain concept up and running, I think it's going to be like HTTPS. So it's going to enable lots more use cases, and there are going to be a lot of them. So at the moment, you're probably looking at YouTube over a secure connection. There are probably be billions of these connections, maybe trillions. Yeah. One extra thought on the two sidechains interacting is as well that, so what we're working on in Pegasus is right at the moment is Ethereum to Ethereum. So I know I had Ethereum to EOS in that other diagram in the earlier slides, but right at the moment we're working on communication between chains and sidechains on demand for Ethereum. Another thought on the overall structure and how this might play out is that you can imagine you may have a hierarchy of chains. So not just one single blockchain, but feeding up to mainnet, or having like lots and lots of them all feeding up to mainnet, because that's not scalable. It's just not possible. So what you could imagine is you could have some sort of delegate tree structure, essentially. But you can still communicate between chains that aren't part of the same pinning tree. Obviously, there are some issues with finance. So the, not sure if you'll be able to see the mouse cursor here, but that down there, that chain there down towards the bottom, it won't become, it can put a pin into the blockchain above it. But until that actually ends up on mainnet, then you're not going to have that chain actually pinned and hence irrevocable. So a few more thoughts on sidechains. So the intention has been that the Ethereum private sidechains that we're working on, they're not a scaling solution as such. So they're not trying to compete with Ethereum 2 and the sharding efforts, but they will provide a bit of scaling. It hasn't been designed as an experimentation solution, but it will allow experimentation. And so what I can think is that chain, you've got what I think of as blockchain physics. And so coming from the same way that if you're working in a computer game and you've got computer game physics. So for instance, when you drop a ball, it might drop to the ground at normal speed, you know, just as if you're on Earth, or it might drop a lot slower. Or say when you're driving a racing car, if the physics of our world were actually in most computer games, then most people would die and have crashed their car immediately. Whereas in a computer game, normally the settings are such that the physics mean that you can drive the car and have a nice computer game. So from a blockchain perspective, that blockchain physics, you know, you could be, say, altering the amount of gas that you charge for each instruction. Or you could decide not to charge gas for anything. Or you could charge rent for usage of memory locations. You could have a different gas limit. You could have a different EVM version. So maybe for your consortium, you want to use EVM version, I don't know, some version. And even though mainnet and other chains have moved on, maybe you want to sit with the past. You know, so that would be something else. It would be part of the overall blockchain physics. So look, I've written a research paper, which is available on Archive. It talks about, well, what do you need to do a one of these side chains? And, you know, what are the requirements you're looking for? It analyzes quorum, Hyperledger Fabric, and parity, and then proposes some thoughts. So it gives you a bit more of a feel for the private side chains. So what about the future? Where are we at? Where are we going? So before I launch into this, so the top half of this is really Ethereum Foundation and, you know, organizations such as Pegasus that are working with Ethereum Foundation. And the bottom part is Pegasus itself and what we're doing and where we're going. And so with the Ethereum Foundation work and the Ethereum 2.0 stuff, which is, you know, the proof of stake and sharding, it's research in the open. So, you know, like normally you might have a research group and, you know, they get to talk, discuss, kick ideas around and then maybe publish a paper. Whereas the way it's being done is very much out in the open and public. And so dates, you know, we get discussed and ideas get thought about and, you know, they get kicked around a bit. So, you know, take these dates as they've been said, but, you know, if they aren't met, then I think, you know, it's not a bad thing either, because maybe there's working on a slightly different, maybe better approach. So the thought when these slides were published was that 2019, maybe we can have a proof of stake and idea, and then maybe 2020, maybe we get to sharding. And then maybe a little later we get to some all singing, all dancing merged thing. But I think since then there's been talk about Beacon work, just prioritizing work on the Beacon chain. And so look, if you want to find out more about Ethereum 2, have a look at Brett Henderson's talk in the Ethereum Engineering Group meetup. It's he did a talk about a month ago or so on Ethereum 2, maybe 2 months ago, and it's a pretty good introduction. So for Pegasus, we've launched in October, and so at DevCon, and so it's available on GitHub. So yep, you can get the Pegasus source code. And if you can't find it, please post a comment on this video and then we will help you out to find it. We're looking to, in this coming year, probably first half, but I don't think there's any product management people on the call, so I think that's approximately correct, that we're aiming to get something out for enterprise, you know, pretty soon. And then, you know, the all singing, all dancing, multi-chain, sidechains on demand, we're working on it. And I don't want to give us, you know, because I guess the dates that we talk about, we're talking about in production. And so, you know, maybe we have some alpha which is available sooner, and certainly for some pieces such as the ERA, the Ethereum Registration Authority, they're already out in the open and on a public GitHub repo. But, you know, so we're going to move towards that sidechains on demand stuff. And, you know, for my own, I think having the Ethereum, the enterprise Ethereum work and the public Ethereum, I can imagine there'll be a time when the two of them will be the same, you know, and that, say, sidechains on demand will just be part of the overall thing, potentially. So that's my own thought bubble, and I'm sure other people have different opinions. So another thing is that about the blockchain's ability to migrate and change and fork and learn. So Bitcoin has inspired Ethereum and many others, and Ethereum has inspired many others, and those other platforms have inspired others. But I think if a blockchain platform can be inspired by and can, you know, take the good work from another blockchain, then that's great. And so I think Bitcoin have had a few troubles with, you know, updating, and I think Ethereum, I think it, you know, like if you look at, say, Polkadot and you look at Ethereum 2, there are some similarities. And so I'm not saying, you know, who was inspired by who, but it's certainly an interesting thing. And I think there are other platforms as well that'll probably inspire Ethereum. But I think Ethereum's capability of doing these forks mean that as other platforms come up, if they end up, you know, having some great ideas, then I don't think anyone should be too proud to say, oh, that's, you know, that's great for them, but it won't, you know, we can't possibly do it because, you know, we're the best. I think that the Ethereum community is pragmatic enough to look and say, all right, well, that could fit into this architecture in this logical way, and then evolve with it. Again, I'll be very interested to hear people's perspectives. So we've got some meetups coming up. In particular, in 2 weeks' time, we're going to be talking about Ethereum standards for consortium networks. So I think that'll be really interesting. And then in 4 weeks' time, we're going to talk about, from a high-level perspective, Pantheon, and give an introduction to what a lot of the people in Brisbane in Consensus have been working on, which I think that'll be really exciting. Well, generally for everyone who's interested in Pantheon, but in particular for people who are in Brisbane to understand what we've all been working on. So with that, are there any questions? Grace, I know you're busting to ask a question. your new. Oh, so for the people on YouTube, Grace is reasonably new to Pegasus. So, so Grace, please.
I think the one thing that us non-technical people, I guess for everyone, I am from a strategy and business development perspective, so this is very technical. And I think kind of the transition from, the research to the how do you bring this to business kind of transition interests me the most. I don't think you really highlighted that specifically, but more on the technical side. Have you considered that at all, or is it still in the works?
No. This is something that we actively talk about, and so we're in active discussions about how the sidechains on demand work will progress into our Pegasus and to our Pantheon client. And so the goal is to give everyone the in a staged approach, the technology. So yeah, technology transfer is a big thing. So we're also working on Beacon Chain, or not the Sidechains group, but the Ethereum 2 group are working on Beacon Chain, which will help us move towards Ethereum 2. So, yeah.
That makes sense. And I also found it interesting. So with your timeline, I think you had on maybe a couple slides back with what that timeline was. You kind of highlighted from a high level how you kind of prioritize those, but I'd be interested to kind of hear more about how, you kind of said ballpark, 2020 sidechains might be that evolution. So.
Yeah. How do you come up with dates for these things?
Yes.
Yeah. I mean, this is the thing. I could have said Q1 next year as well. In fact, it was very interesting. I was on a panel discussion on Monday, and a question that I put up was, if you could have any feature, blockchain feature, and have it magically available now, across the community, not just your product, but everyone has it, what would it be? And for me, it was that magical cross-chain inter-ledger, protocol where one blockchain can fire something off at another one.
Interesting. Yeah. It'll be interesting to see how the prioritization changes or doesn't,
Yeah. I have some thoughts. We can talk out once we're not on a YouTube video. John, what do you... I saw you go off mute there, so you've got some thoughts.
Isn't there a significant question about backwards compatibility when you've got an existing blockchain and now we're adding all these new features? I mean, how do we get them implemented without breaking everything that's already out there?
I agree. That is very true. You've got to be backwards compatible with the past.
For enterprises that may be less of an issue, but for stuff on the public chain, you've always got to keep that in mind, right?
I think it's true for enterprises too. You can imagine throwing out for 2025 a bit. So we've got our all singing, all dancing sidechains workout, I don't know, Q1 next year, or maybe it's 2020. Right. But anyway, we get that out there. The business has, a version of this sidechains on demand, all singing, all dancing thing, and they're, like showering each other with champagne. They're so happy. And we do an upgrade, and each time we upgrade our technology, those, that company, they want to have, maybe we've done some security fix, hallelujah, but then they don't want us to break their application. They've got some mission critical business application. So I think mainnet and public chain, they've got the same backwards compatibility issues where once you've got something established, you can't break backwards compatibility. Yeah. All right. Well, look, thank you everyone for joining the call. It was, great to have you on. And for those people who are watching this on YouTube, I hope you enjoyed it. And please put a comment in. Thanks. Bye-bye.